Hi, ladies and gentlemen. Welcome to a lesson on distributive property, and we're going to be simplifying for today, combining like terms. Chapter 3, Lesson 7. Let's go ahead and pause your video, check out your answers from assignment number 23, and come on back when you're ready. All right, goal for today, today's learning target. I will use the distributive property to simplify expressions. Things like doing 2 times 17 in your head if it's too big. You can do 2 times 10, 2 times 7, more on that later. Along with 32 plus 4f minus 10, can we use our properties, including the distributive property, to kind of combine like terms? Now, think about it. We've been working with 1 and 2-step equations. We're now going to use these properties to simplify and solve more complex equations in the future. So that's where our goal is. That's why we want to learn today to use that distributive property to simplify. Go ahead and pause your video, whatever today's date is, hour, and then come on back when you're ready. All right, folks, let's put a few examples right underneath assignment number 24. I'm going to encourage you to write a bunch of examples today. It's okay if you need more than one piece of paper for today's assignment. You know how I feel about recycling. We'll take care of the environment, but you might need the space. I want you to think about what distribute means, all right? When you think about the word distribute, it means giving out and making sure to be fair. It would not be fair to give some money to you and not to your classmates. It would not be fair to give you a day off from your homework and not do the same with your classmates. Well, mathematically distribute means the same thing. So if I think about this problem, 8 times 5 plus 3 in parentheses, what that really will mean is that we are going to do 8 sets of 5 and 8 sets of 3. Now 8 sets of 5 would be 40, 8 sets of 3 is 24. Put them together and you get 64. Now, I know what some of you are thinking. Come on, Mr. Callan, I could have done 8 sets of 8. Yes, but sometimes it will be valuable to group them together, and sometimes it will be valuable to split them apart. It all depends on the circumstances. Now, what I'm going to do here, I got a few examples. Let me do a few of them, and then I'll give you a turn. I'm going to encourage you, until we get really used to this, to draw the arrows. So you see my arrows above this 2 right here. What that means is 2 sets of 6 and 2 sets of 4. 2 sets of 6, 2 sets of 4. I'm not even going to compute right now. I just want you to get used to the distributive property. I'll go right below that where we have 4 groups. So what do we have inside the groups? We have 7 and 3. So we got 4 groups of 7 and an additional 4 groups of 3. Now right below that, we got 4 groups of 5 minus 2. So what does that mean? 4 groups of 5. So you just have 4 times you're going up 5. And then 4 groups of negative or minus or decreasing 2. So 4 sets of 5, 4 sets of 2. Now I'd encourage you to pause your video, try these next out, and don't forget to draw your arrows. So 3 groups of 4 plus 2 literally means 3 groups of 4 and an additional 3 groups of 2. We also have 3 groups here, even though it's on the right side. What are the groups? Well, we have 8 and 1. So that means if you split that up, you'd have 3 groups of 8 as well as 3 groups of 1. And yes, it does work for subtraction, 7 groups of 3, and then going down to 7 times. So 7 groups of 3 and minus 7 groups of 2. Again, there are times when you want to keep them together. There are times when it's going to be helpful to split them up. Now let's go ahead and do it in reverse. This is when you would want to bring them together, right? So here on example G, we have 3 groups of 9 and 3 groups of 6. But wouldn't it be nice to put them together and say that's 3 groups of 9 and 6? In like manner, with example I, we'd have 4 groups of 3 as well as 8, because both of those are 4 groups. 4 groups of 3, 4 groups of 8. Example K, we have 9 groups of 7 and 9 groups of 3, so why not just write 9 groups? And notice this one has the 3 that is subtracted, because 9 times we're going up 7, and then 9 times we're going down 3. All right, let's see if you can do this now for the other 3 examples. Pause and come on back when you're ready. So 6 groups of 17, 6 groups of 3. It could also mean 6 groups of 17 and 3 together. Maybe I'll stop drawing the arrows now. 7 groups of 3, 7 groups of 6. means 7 groups of 3 and 6. 12 times we go up 8, and then 12 times we go down 6. Well, that's kind of the same as saying 12 groups of going up 8 and down 6 and up 8 and down 6 and up 8 and down 6. Now, again, why would we do this? Where is the distributive property going to come in handy? If you think about 17 times 6, yes, you can come off to the side and you can multiply out. 6 times 7 is 42. Or is there an easier way so that we can compute it mentally? And in this case, there is. Think about splitting up 17 into 10 and 7. Now remember, we have 6 groups of 17, so that means 6 groups of 10, which is 60, 6 groups of 7, which is 42, and if you put 60 and 42 together, then you're going to get 102. So the idea is eventually that you can do all this mentally. Not today, not now, but eventually. And some of you might already have that skill because you have such strong number sense and computation skills. Sometimes it helps to keep them together, and sometimes it helps to split them apart. In this case, I wanted to split apart 17 into 10 and 7 because I know 6 10s and 6 7s pretty easily. So let's try to do that. And this is important because tonight's homework, it's going to say compute mentally or use mental math. I really want you to show your steps at least for today. Let me say that again. I really want you to show your steps on this for today's assignment. So think about taking 7 groups of 23. Essentially, what we want to do in our mind is 7 groups of 20 and 7 groups of 3, which means I can split that up. And if you'd like, you may use those arrows. I would highly recommend it, at least for today, if not for longer. 7 groups of 20 is 140. 7 groups of 3 is 21. So I can put that together now to make, you guessed it, 161. Let me slide on down. I'm going to do another example. 5 groups of 103. Well, you know what, Mr. Callan? I can do 5 groups of 100 pretty quickly. And I can do 5 groups of 3 pretty quickly. Oh, okay. So 5 groups of 103 would be 515. At this point, why don't you go ahead and do a couple examples. Some of you are getting this. You've actually already learned it. You've already known that distributive idea. You just maybe never called it the distributive property. So go ahead and pause, fast forward if you need to, do whatever. Come on back when you're ready. 8 groups of 31, you could say, is 8 groups of 30 and 8 groups of 1. Oh, I got that, Mr. Callan. 8 groups of 30 is 240. 8 groups of 1 is 8. So put those together. 8 31s will be 248. 9 groups of 204. Well, you could split up the 204 into 9 groups of 200 and 9 groups of 4. Then we have 1836, which put together makes 1836. So pause if you need to. Think about how sometimes it helps to split up 23 or 31 or 204 or 103 when multiplying mentally. Although for today, I want you to show the work. Let's go on and do something more algebraic. So not just numbers, but now numbers and symbols. Okay. So 3 n's and 4 n's and 7 n's. Well, kind of can feel what that means. If you got 3 envelopes of money, 4 envelopes of money, 7 envelopes of money, then you have 3 plus 4 is 7, plus another 7 is 14 envelopes of money. Don't forget that n, right? Example B, 5 n's plus 1 n plus 1 n. Now, I am totally a 1 kind of dude. I like to write in the ones. You don't need to, though. So 5n plus 1n plus 1n, well, go ahead. Oh, look at there. I put it right down below. 5 plus 1 is, yep, 7, but not just 7, 7 envelopes of money. We still don't know how much money that is, but at least we have simplified. Let's look at this bottom one. 14 C's plus 2 plus 10 C's plus 1. Let's group those like terms together. Let's put the C's together. 14 C's, 10 C's is 24 C's. But then there's a constant term. Why write plus 2 plus 1 when we could write 3? So I want you guys to think about that. The whole idea is to simplify our lives. Why write something in 3 separate terms when we could use the distributive property and combine those like terms? Why write 5n plus 1n plus 1? That's 3 different terms. We can rewrite it as one term. Why write 14c's plus 2 plus? That's 4 terms, and we simplified it down to 2. It's all in the effort of making our lives simpler, combining that like terms. Now let's go ahead and use those ideas together with a little bit of mental math as well. 9w's plus w plus w. Okay, don't try to do all that multiplication and then add. Combine those like terms first. 9w's plus an extra w is 10w's plus one more is 11. Okay, 11w's, 11 times 60 is 660. For example, E. Why write v plus 7v plus 3v when we could just put those together and say 11v's? All right, now 11 times 20 would be 220. So this is how using combining of like terms and a distributive property will make our lives simpler. So now we go to the homework, folks. I considered trimming some problems down. Forgive me that I haven't done that yet. I got 16 minutes, so I'm kind of worried this is a little long for you. I think you can handle it, although it might be kind of a tougher day, so sorry about that. Do well. Check your odd answers in the back of the book. I'll come back with the evens tomorrow. Let's grow.